She actually puts out those. Puts out 110
yeah, like I said, this system's in the gym. This system's all over. This system's outside. ERA, environmentally responsible radiation.
Okay, so are the emissions really a problem, or is it like
then you have your gas exchange through a permeable membrane, and you keep it as a closed system. And you have lighting in there, you have a little density measurement to see how the little specimens are growing in the end, a little stirrer, and all this fits in a double size of these containers. Design something on there.
There's only so many left.
I like that.
Augmentation. Actually, it's 3 augmentations. We put some new filters. Right now, the filters are clean water and the filters. But we got to have some.
It's.
Do you have to put it all in a glove box if it's anything that's...
As I came on board and started interacting with the rest of the folks in the program and started looking at, from my perspective as a member of the research community, what we wanted to do in terms of providing new opportunities and for reinvigorating the community such that we have the capacity, research capacity, to be able to utilize space station. So, we're working basically to reestablish research opportunities in space and physical sciences in terms of annual NRAs. And so I think
risk reduction activities with a very finite amount of funding and a very increasingly short timeline to accomplish all of these things, specifically to enable astronaut safety, health, and performance on long-duration missions beyond low Earth orbit and exploration of the solar system. We invite your help in solving the problems, and if there's a need for any more information, of course, we'll have the panel discussion, and feel free to follow up with me at any time, either during this meeting or afterwards. And I thank you for your kind attention.
I've just been brought into the ISS Research Integration Office, and she'll be coordinating, helping people that are developing proposals to get, among many duties, to get feasibility assessments. So what we do is the Research Integration Office does a letter to go with each proposal that says, yes, we've looked at this, it fits, it'll fit on a standard interface, we have launch capacity, so that any of those kind of programmatic things that SMD might not know about are covered in the proposal so that they can be comfortable that if they select it, it's a doable project.
But it does come down to relationship building and people, and getting people to know each other and getting people to trust each other. And the way we've been doing that in OCT is twofold. First, at the headquarters level, and then at the level 2s where the program offices are for OCT, we are trying in every solicitation or in every selection
slower than what we see here on Earth due to buoyancy-induced convection. So now when that molecule comes in, and they're going to come in upside down, all different ways, they have time to bounce around, find the right position before the next one comes in and traps them in a misorientation. And that is one reason why we think the crystals from microgravity are often of higher quality. Another reason is that every time we purify a protein, we have the purified monomer, one molecule of the protein in the solution, along with aggregates, dimers and trimers. They all have the same charges on the outside, but in aggregate, the two molecules are closer together.